All right, so this is our final meeting together in a lecture. There's lab this afternoon, and of course the final exam is on Wednesday at 12 o'clock in here, 2 hours. I got that question. I can read your mind. Very good. So what do you want to do today? Review for the final, can I assume that? Yeah, okay. The area that would be the sort of the riskiest is classes. Is that right? That's the area? Okay. So let's take a look at classes.
Last lecture we worked on number class.
So, say one more time.
Last lecture we worked on a number class.
Oh, number class, yeah. All right.
So today we might work.
Did we finish that?
Yeah, there you go.
Oh, we did the, I see, okay. So we could do something different then, right? Let's see. Let's see if there's any examples here. Point class. And there's this rectangle class, number class, bean jar class. Did we do this?
Yes. No, we didn't.
We didn't do this. Let's do the bean jar class. So here's the this is the declaration of the class, and look here, this is the description of how the functions work in the class. So there it is. Here's the class declaration. Let's look at the questions. Here they are, 10 questions. Draw the UML class diagram. Provide an implementation of the bean jar constructor. Provide an implementation of the getBeans function. And provide an implementation of remove all beans. And 9, provide an implementation of the addBeans function. And 10, develop test code. Make sure the test code provides good coverage in the sense that it executes all lines of code in the addBeans function. Use the assert function in your code. So let's do this. So here we have, is that too small?
No, that's fine.
All right? Too small, it's okay. So instead of reading this out loud to you, I'm just going to explain it. This is the constructor. It takes 2 arguments. The first argument is related to the size of the bean jar. It's how many beans the jar can hold, its capacity, max beans. The second argument is how many beans will be in the jar, when you first create this bean jar instance. So, this class is trying to model the real world. Maybe you have real bean jars. And in the computer, you want to represent those bean jars that you have with these, with this data. So you have the size of the jar, or max beans, and the beans that are in the jar. Now you can change the beans that are in the jar. You call add beans. That's to increase the number of beans in the jar, to add beans to it. But you can't add beyond the capacity. So you can't go beyond max beans. Well, down here, this is the member variable max beans and the member variable beans. Beans is the number of beans in the jar. Max beans is the capacity of the jar. So if we want to change how many beans are in the jar, we can call add beans. So if we have 10 beans in the jar, we want to add 5, we call add beans, pass in a 5. Now it has 15 beans. Now when we call get beans will return 15. That's how many beans are in the jar. Calling get beans doesn't modify the member variables, so we can declare it const or constant. But add beans can modify the member variables, well, one of them, beans. So we cannot declare that as const. Remove all beans, that just takes all the beans out of the jar so the number of beans in the jar becomes 0. That's very easy to implement, remove all beans. Think about that. How would you remove all beans? What would your implementation of that function look like? What would it do? What do you think?
You just set beans to 0.
Exactly. Just set beans to 0. That's it. Good. Add beans is a little tricky because if the beans are being asked to add, which is beans, the beans are being asked to add, if you were to add it and have it exceed max beans, then we should refuse to add those beans and return false to indicate to the calling code that we did not accomplish that task. That's just a way that we designed this code to work. So add beans returns a bool, true if it accomplished the addition, or false if it didn't accomplish the addition because we were asked to add too many beans. So let's take a look now. The UML class diagram, let's look at that. The UML class diagram has 3 sections. The first section just gives the name of the class. The second section is the member variables. The third section is for the member functions. So the top section is the name of the class, bean jar. The second section is the member variables. There's 2. The first one, they're both private. We've got max beans. That's an int. And we have beans, which is also an int.
So
Yeah.
whatever we have in private, it goes in a variable.
So the thing about these variables, they're usually private, but they don't have to be. So if we put max beans in the public section, then we'd want to indicate that in the UML diagram with a plus right there. Yeah.
Why we cannot put integer get beans into the variable?
Into, like here?
Yes.
Well, it's a function.
Oh, that's function.
Yeah, get beans is a function. See the parentheses here?
Okay. Got it.
You know it's a function if it's got parentheses. Oops. Now, for the functions go in the third section. So there's the constructor function. The name of the constructor, and that is public, by the way. The constructor function always has the same name as the class. And that's normal for a language like C++, Java, C#, those languages. There's two arguments. Max beans is the first one. That's an int. Beans is the second one. That's an int as well. The one thing about constructor functions is they're not declared as returning a value. So you don't see a void in front of bean jar. Right? You don't see this. It's a function. It's kind of a special function. So we don't do that. We don't show a return type for constructor functions. The purpose of the constructor function is it gets run when the program allocates storage to store an instance of the bean jar class. The constructor function is then run in order to initialize that storage. So what do we need in storage? Just these two things. So the constructor is responsible for initializing the state of the member variables. Now we have getBeans. GetBeans is a function that takes no arguments. It returns an int. And then we have addBeans. AddBeans takes an argument, but it has no return value. If you want, you could put a void there or just leave it empty. I leave it empty, but if you want, you can do that. But I usually do this. Then we have remove all beans. All these functions are public. They don't have to be, but they are in our case. Remove all beans. It doesn't take any arguments. It doesn't return a value. There it is. Yeah.
Why doesn't addBeans return anything if it's a bool? What did it return?
Oh, yeah, I made a mistake. Thank you. Thank you. This should be a bool. Thanks. See, it's the UML notation that data type is placed after the variable or function name. That's the opposite of the syntax of the language we're using. But this notation is not just for C++, it's for any language. Yeah.
In UML, in this diagram, we don't have to put the void in function, right?
You don't have to. I mean, you can. It's probably not a bad idea.
Okay.
Maybe that would be more common than leaving it out. All right, what about an implementation of the bean jar constructor? I'll show you what I accept on the final exam for an answer. Well, there's a couple of ways of doing this. You don't need to repeat the constructor function signature, I'll call it, or declaration. But I'll do it here just to help you see it better. So we've got, our member variable max beans is set to the max beans that's being passed into the function. Same thing with beans. So here we have code that initializes the two member variables, max beans and beans. It simply copies the arguments passed into the constructor. It just copies those arguments into those two member variables. Now they happen to have the same names, so although they represent different places in memory, that's why we have to do the copy operation to move from one memory location to the other. But they happen to have the same names, so we need to distinguish between the two of them in some way. So we use this notation here. We put that as a label in front of the member variables. We didn't have to do it like that. You could do it like this. You could give these different names. We'll call this B for beans. And for max beans, we'll call it MB. So now, this becomes B, and this becomes MB. Well, in this case, there's no naming conflict, so we can remove this special notation. So that's an acceptable alternative. I'm going to show you some more alternatives. You can use an initialization list. So instead of setting things using that assignment operator, you can set them in the initialization list like this. Well, I'll make it look like this. So that's okay. That does the same thing, just an alternative implementation. And it's the same with this. You can use, if you're using the same names, max beans here and beans, it would look like this. So there's 4 different ways of writing the constructor. Use the one that makes the most sense to you. But ultimately, if you're going to study more of this language, you'll need to be familiar with all of these forms. How about provide an implementation of getBeans? We just want to know the value of beans. So we just return beans. That's it. Now on the exam, all you need to write is this. That's good enough for me. All right. Just the implementation part, not the declaration, because that's already there. It's already up here. We don't need to see that repeated. But if you would like to repeat it, you can. I'll repeat it here just because it's hard to see, because this area scrolls off the screen when we work down below. What about add beans? No, I want this one here, add beans. I'm sorry, remove all beans. Remove all beans, and this is add beans. Remove all beans. It's very simple. We already talked about this one. We just set beans to 0. That's how we remove all the beans. These are the member variables beans, so you could do this. Some languages always require this designation. I think Python does. You work in a Python language, you always have to put self in front of the variable if it's a member variable. I think it's called self. I don't work in the language enough to remember the details. Yeah.
While we're running the functions, do we have to put bean jar : remove all beans?
Oh yeah, I should do that, but you actually don't need to write the function.
Okay.
So, but actually in code, it needs to look like that. But once again, I'm not going to worry about that. But yeah, in real code, it has to have that. What about add beans? I'm going to make it simpler for you. I'm just going to make this a B. So really, we want to take beans and add into it B. But you know, that could be a problem, because what if the resulting beans is bigger than max beans? So we got to check for that first before we do the addition. So if beans plus B is bigger than max beans, then we're going to return false. We can't do it. Otherwise, we can do it. And of course, we want to return true. I'm always spelling that wrong. Okay. See how that works? If beans plus B is bigger than max beans, return false. Maybe that's hard to read. I'll let you decide how you want to do that. Maybe you want to do this. Maybe this is easier to read and understand. So you could do it like that. Oh, it's not indented correctly. There we go. Or if you wanted to, these are all, I'm showing you all equivalent ways of doing this. If you used beans here, then this has to be this beans plus beans. And this would be this beans plus beans. So if the argument has the same name as the member variable, we need to distinguish between the two using that this arrow notation. We didn't have to put it in front of max beans, but it doesn't hurt. You could put it there if you like, because there's no naming conflict here. What about test code for add beans? And make sure it executes all lines of code. That means we want to make sure it returns a false and then another test case to return true. So let's create an instance of the bean jar, call it J1. Max beans of 100, initial beans of 50. And then we call assert J1 dot add beans. Let's add 25. So this should return true because that should succeed. Remember, add beans returns true if it can add those beans. It returns false otherwise. I won't call it J1, I'm just going to call it jar. I'm going to keep the test code really simple. you know, test code, it's good to have a lot of tests, but, you know, on the exam, I just want you to provide a minimum. Let's pass in a bad test here. See, after we add 25, there's 75 beans in the jar. So we try to add 50, we can't reach 125 beans because the capacity is 100. That's what we created. We created a jar with a capacity of 100 beans. If you wanted to, you could add another assert in there, but it's not required for the exam. I'll call it get beans and see that it equals 75. And when we call it get beans the second time, it should still equal 75 because we weren't able to add the requested 50 beans. So this is good code, but the requirement is, I mean, this is actually pretty good basic code to have these two assertions in there as well, because that just checks to make sure that the addition was done correctly if I add beans. So I'd say that's a good test for the exam. Yeah.
So 100 is the maximum amount of beans, right? And how about the 50? Where is 50 from?
100 is the maximum beans.
Yeah.
The 50 is how many? The 50 is how many initially when the jar is created.
Oh, initially, okay.
How many beans are in there initially? So it's half full. And you know, most software these days is built using this kind of code you're seeing right here. This is how they do it. It doesn't make sense now, does it? It's like, what am I doing this for? But actually, when you start writing code, it's full of classes and member variables and member functions. It's just all over the place because the problem is this. The system, normally a program is very complicated. It's not normally simple like what we've been looking at in this class. It's normally very complicated with thousands, if not millions, of lines of code. And so it's so big and so complicated, you need to make it readable. So you build things to look like these objects, like a bean jar. Like, oh, I've got a bean jar. And I create a bean jar instance. Or maybe you want a web server. It's like, oh, I need a web server instance. I create a web server instance, and I need to start it up. So I'm going to call the start function on the web server. So it's all designed as a class. You see how nicely that works? And it encapsulates a lot of logic. I mean, a web server is got a lot of complicated details to it. But if I can just instantiate a web server, if I create a web server and then I just call start on it, like I remove all of that complexity and details. Oh, I've got it. You're thinking in terms of things like, oh, I've got a web server. You know, I've got an instance of a web server. You can have multiple web servers. This is a web server. And then I start it, and then I'll do something, and then maybe I'll stop it. You see, but this web server, what does a web server have? 10,000 lines of code, you know, for a small one? Well, not a small one could be smaller than that. Maybe 2,000 lines of code for a small web server. And then you create the instance of it, you start it when you need to, and you stop it when you need to. There, see, you're not seeing 10,000 lines of code. You're just seeing 3 lines of code. But you can reason, oh, it's a web server, it's a thing. See, so we're thinking in terms of objects with behaviors. I can stop it and start it. Do you see how that makes it easy to organize tens of thousands of lines of code so you can think about it more easily, manage that project more easily? So that's how that works. So I just want you to know that what you're doing here is not meaningless, of course, unless you're not going to get into programming, then it might as well be meaningless. But if you get into programming, this is This is how the code looks normally. This is the current style that's evolved over the recent decades. It'll keep evolving. I'm sure the future style will look different. But it hasn't been changing that fast. It changes kind of slowly. But it is changing. All right, so what about the time? We're still okay here. Any questions about this bean jar class? Anything more? No? There's another class we could look at, the egg carton class. It's very similar to the bean jar class. It's got these questions here, like get total weight. Like if you create you've got an egg carton, okay? Create an instance of egg carton. The constructor takes how many eggs are in it. So all these cartons have 12 eggs. So they're not different sized cartons. They all have 12, but they can store different size eggs. We're allowing the eggs to be different sizes, but not the number of eggs. So we pass in how many eggs we want to be in that carton, and we pass in the average grams per egg. So that means we've got this function, get total weight. Well, it's just eggs times grams per egg, right? That's the total weight. Yeah, roughly, we're omitting the weight of the carton. Then there's an add eggs function. Just how many eggs do we want to add in there? And it returns a bool. Did it succeed or fail? It's similar to a bean jar. And use test codes. It's very similar to the bean jar class. Yeah.
Can we do this?
Do you want to do this? Yeah. Everybody? Okay. Let's do this. How would this look on the exam? Okay. Provide an implementation of the egg carton constructor. If you want, you can do this. Actually, probably you want to put the constructor in there. We'll do egg carton
integer.
What's that? So eggs, that's an int. Grams per egg, that's a double. Well, the easiest way to do it is this. There's one version of the constructor that works. What about add eggs? Add eggs returns a bool. Now we don't want to go beyond 12. So if our current eggs, this eggs, plus the eggs we want to add, if that's bigger than 12, then return false. Can't do it. Otherwise, let's go ahead and add them in there. And return true. First, we check to see if it's feasible. If not, return false. If we pass that test, then we're going to go ahead and add the eggs in there and then return true, saying that we succeeded. What about get total weight? Get total weight returns a double floating point number. Oh, not bean jar, it's an egg carton. Should be a const. We just return the number of eggs we have in the carton times the grams per egg. You know, once again, we're not ignoring the weight of the carton, and we didn't use the word average for average grams per egg. We didn't do that. You know, it's just sort of, this is how we define this problem. This is how we're going to do it, for whatever reasons. What about test code? Let's create a carton with 3 eggs, 1.2 grams per egg. I don't even know how much a gram is. That's too small, right? What's a good number of grams for an egg? I don't even know. 100? Is that too much? How many grams in an egg? 30? Come on, someone knows grams. Anybody know grams? Anybody not from the United States in here? Everybody's from the U.S.? Nobody from, well.
About 50.
50?
Yeah.
50, thank you. Well, let's say 50.3, just to have a number in there, to show it's a double. 50 grams. So we create this carton, and then let's call, what we want to do is add eggs. We want to test the add eggs function. We're not worried about the other functions. Of course, we have to use the other functions. We need to use the constructor, which we do here. Then we use the add eggs function now. Let's add 7 eggs. Now there's a problem with the testing the weight, because if I take the carton and I do get total weight, what do I compare it to? Like, it should be 503, right? Because that's 10 times 50.3. But that's a problem because this 0.3 doesn't have an exact representation, or may not have an exact representation in computer memory. So there's some round off error. Yeah.
What does the number 3 represent?
0.3. Oh, this?
Yeah.
How many eggs are in the carton?
Okay, initially.
Initially. We're adding 7. That's going to give us 10 eggs.
Okay.
We don't have get eggs, do we? So you can't call it get eggs. So this, you can't really test this. It should be, approximately equal to. 503. Because of when you're using doubles, you get potentially get round-off error. Normally, you get round-off error. So you may not get that get total weight equals 503 exactly. Because internally in the system, it's storing these numbers as binary numbers. How do you store 0.3 as a binary value? There's no exact, there's not an exact, it's not represented exactly internally in memory. It's represented approximately with bits in these bytes. And so when you do things like multiply, you've got a representation of a number which is approximate, and then you multiply by another number, 10, and then you're compounding that round-off error. So you can't. So you'll need to test that it's within a certain range, within epsilon of a. We'll do something like. But I don't want to get into that because you've got enough to think about. But you would want to check to see that get total weight was within epsilon of 503. Epsilon being say 0.0001, something like that. I'm not going to get into that. But what if we try to add another 7? Well, that should fail because that would give us 17 eggs, and we can only hold 12. Anyway, this is not testing this issue here, get total weight. We don't need to, the problem is not to test get total weight, it's to test the add eggs function. So we really don't need to think about that right now. So that's this problem. Yeah.
Can this go down a bit? Why is one is true and another one is false?
Well, how many eggs are in the carton at this point in the code?
3.
How many eggs are in the carton at this point in the code? 10.
Oh, and then we are adding 7 more, so which is.
Yeah, I can't do it. This should be dot add eggs, by the way. Yeah.
Why is it carton dot eggs? What is a carton?
Carton is the name of the variable. Here, we create an instance of the egg carton class. We call it carton. So the name, if we called it C, instead of carton, then we'd have to call everything by C. See, it's just that's the name that we chose in the code. You can use C. That's good. Or X, anything. I don't think X is a good choice, though. I mean, I use the word carton because it was readable, in my opinion. Wait a minute. Maybe just briefly look at some real code. So this is that problem I was showing you before, where you have this grid at the beginning of a video game, just playing around with this square that I can move in there. I hit escape. So I've got these classes, player, and I have a utility class. And if you look at the code, you'll see where I use things like, this is the draw method. This is where I want to draw the grid. This is where I draw the player. The player is a dot in the grid. This is where I want to call process event. See, this function call here gets an event. There's an event queue. So in the computer, you've got things happening. The user is moving the mouse, clicking the mouse buttons, moving the mouse wheel, typing keys on the keyboard, clicking the shutdown button on the window or the minimize button. These are all events that are passed as information to the running program. And they come in, so when I call, and they queue up, they get into line. They get into a line called a queue. So they queue up, and so what we want to do is pull off the frontmost event one after another. So every time we call SDL poll event, we pop off the front of the queue a waiting event, an event waiting for us to handle. And we store it into this structure here, E. So E is of type SDL event. And we check, there's a member called type in that struct. So we compare E.type to this constant, which is the code for the down arrow key. It's the code that means that the type of event, it's a key down event, as opposed to a key up event, or a mouse move event, or a left mouse button click, or a right mouse button click event, or a window closing event, a timer event. There's a whole bunch of events you could get informed about. We're just concerned about the key down event. So if we get a key down event, and the key that's being pressed down is escape, then we're going to return false. You see, I'm looking at things. So I'm using these classes to write a program. Here, this is where we create a new grid instance. This is where we create a new player instance. We didn't look at this syntax yet. You'll get that in Computer Science 202 next quarter. So this is another way to create an instance of a class. Use what's called the new operator. That returns a pointer to the object instance as opposed to a reference. Because that won't be on the exam, but just to tie it in a little bit. And I want to show you, I was playing around with stuff here. Where did I put that thing in? Oh yeah, biz. Let's see how it shows up here. So I'm just playing around with that pixel code I started. I just wanted to see what kind of special effects I could get. Just going to see how this works. I'm just playing around I'm using a random number generator and kind of like, it's like a painting that's moving all the time. Actually, these are balls of color that are dropping down at different rates. So to get this, sort of a slow, contemplative type of thing. You see there's like a ball over here in the upper left-hand corner, and they're different colors. And those are pure hues. So I've got all this infrastructure, start disk, start scene, updatable. All these are classes, and I'm using that to put together this program. This is the main function right there. Look how simple that is. I create an instance of app up here. I'm going to call run. That's it. When run returns, we return 0. So that means we got to look at app. This is the header file for app. It's a class called app. And this is the run method we looked at right there. These are other public functions. This has to do with, pixel locations. And now I'm getting ready. I didn't use this updatable yet, but I'm getting ready to do other stuff to make the program do more. And these are the functions. See, these functions are private. Init, loop, shutdown, draw, clear screen. These are declared as private. So we give them restricted scope. We don't have to give them public scope. But these functions are needed by other classes, so I give those public scope. These are member variables. See, it's more than like one or two. There's a lot of member variables, 2 vectors, and a whole bunch of other stuff here. And then if you look at this is the implementation file. This is the constructor, app. These are member variables that I'm initializing. Here's the run method. Look at the run method. That's simple. We call initialization, we call init, and then we go into this loop. We keep looping until the user presses escape or clicks the Windows shutdown icon. And when the user does that, either of those two quit activities, then we return from loop, and then we run the shutdown code to shut down cleanly. So, this is how you build programs. Just start defining these classes and building them out. That's the way to do it incrementally, so you don't design everything all at once. You just sort of have an idea about where you're going and start building the parts to it and have a sequence. You build a sequence of runnable prototypes. Each prototype gets more and more functionality until finally you're at the point where your program is usable for whatever purpose you're building it for. And then it's then used by users, and maybe you keep working on it. You still have bugs to take out, you have more features to add, and so on. Any other questions? 1 o'clock. We looked at these, yeah.
Are we going to have a question like exercise 1 in exam? The rectangle one?
Yeah. Do you want to look at that one?
Yes, please.
Rectangle class. So implement this class. So we have a constructor that takes a width and a height. I'm doing it this way because it's easier. And this editor is like making it really easy. Here's the constructor. One way to do it. And the area function returns a double. This editor is fantastic. Should be const. We return the width times the height. And the isSquare function returns a bool. Is this rectangle a square? That's also a const. Return width equals height. It's only a square if its width equals its height. So there is the implementation right there. To test, let's say we want to test the isSquare function. Let's create a rectangle R1 with a width of 2 and a height of 3. that means that R1 is not a square. So if we call square, it should return false. Let's create another rectangle, R2, with a width of 4 and a height of 4. That's a square now. So if we call assert on R2 is square, that should return true. This really becomes second nature. I mean, it's just really, really easy to think in terms of classes and objects when you start working with it. When you start building systems, big systems, then it just gets so natural and so easy to think about. But you have to practice it, and pick on your own time. Try to build something. Build like a video game. That's a good way to learn coding. Just try to build a video game, a simple one, not a complicated one. Tic-tac-toe is one that is good. And try to add some graphics to it using something like SDL, like I'm showing you. That's another good way to try to learn. Anything else? All the other problems will appear on the final, by the way. So make sure that you review everything.
I have a question.
Yeah.
So, for like, what percentage of the test is going to be everything else, and then what percentage is going to be for the last part?
The classes?
Yeah.
Classes will be maybe, let me think, maybe 20 to 25%.
The final was 25%.
Well, the final,
Classes being part of the final.
yeah,
Okay.
20% of the final will test you on classes.
Okay. And since the final is scored like 500 points,
Yeah.
so how are you gonna calculate in our grades?
I'm just going to add up all the points. Like if you have an assignment that's worth 50 points, and you got 40 points out of the 50, well, then you get 40 points. I'll add that to your final exam, to the two midterms. I just add all the points up.
Okay.
So there's no weighting. It's just simply add all the points. Yeah.
So compared to like our first two exams, will this exam be a lot longer?
Not a lot longer. A little longer. Yeah.
One
No, everybody finishes. Everybody finishes.
oh,
Every time I give this exam, everybody finishes.
Final will be contain for loops and all loops and command lines and everything.
Yeah, command lines, you got to know the command lines, the Unix command lines. The command line commands. Command line commands.
And also you will give us for loops and we have to put what is the output going to be.
Yeah, what is this loop? Look just like those exams that you
Okay.
already got.
Exam 1, exam 2.
Yeah, it'll look just like an exam.
Okay.
I think exam 1 here.
Mm-hmm.
Yeah, like what does that print? Yeah,
Okay.
there's a bunch of those on there. And knowing this, like this plus plus and, the post and pre. And, this stuff. Print 220 random integers that are greater than 0 but less than 200. Those kind of questions. Lots of those. Yeah. Something like this. All of I have questions that resemble all of these on the final. Is prime, you got to know how to implement that. This gets onto my final an awful lot, that one. Count occurrences, is all zeros. Or something similar to these, not exactly these. maybe I'll ask for an array is friendly, and write a function that determines whether an array is friendly. An array is friendly if, and then I give some description of what friendly is for an array. Then you have to write the code to decide if the array is friendly or not. Okay. That's it, right? Everybody's set. Okay, good. We'll see.